So let's talk now about soil erosion and soil conservation. We've discussed many elements of soil, how they all fit together and how they are necessary for healthy plant growth, and how the soil is its own habitat, its own ecosystem. So we know a bit more now about how to take care of our plants. And hopefully you understand and can appreciate how soil is a valuable resource. And that resource is non-renewable to a certain degree because it takes a long time for soil to form. And in particular, the rocks and minerals, it took a long time for them to get the size that they are. And so we need to protect the soil that we currently have. And hopefully we could enhance it with biological activity, with microbiology and all the organisms and life. But we need to protect the dirt that we have. So let's talk about how we could potentially lose our soil and some strategies for how to conserve it. So to start us off here with our topic of erosion and soil conservation, we have an image of a dry land habitat, and we can see some people standing in the foreground. Presumably there's a little bit of a stream that happens when it rains. So you can imagine that the banks of that stream being pulled away when water flows. And then also pay attention to the cattle. We have cows grazing the grassland up there. And they too are part of soil conservation or potentially soil erosion if we don't manage the ways animals interact with the vegetation and the soil. So we've got potential for good here, but we also have potential for bad. And we're right on the edge in this photo. And the management practices, the things that the humans do to decide who goes where and when, can play a big part in the future of this soil. So soil conservation is when we prevent the loss of soil from erosion. That's the primary way we're going to lose our soil, is with erosion. But we can also lose soil with reduced fertility over time if we overuse it. We can also have soil acidification. We can have soil salinization, and we can have other forms of pollution, contamination in our soil. Erosion is the big one. That's what we're going to primarily focus on, but we'll touch on the others as well. This image here shows the soil after a fire, and you can see how the vast majority of vegetation has been burned off, and we have bare exposed soil left behind. If vegetation does not move in soon to cover this soil and to have roots growing in it that will hold it in place, and leaves and stems on top that will shelter the soil from wind, rain, even from sun, then we're going to lose this soil. So always after a fire is one of the times we need to be concerned with preserving our soil. Remember how soil forms, that it is dependent on the parent material and the topography. And based on our climate, it will form at different rates. So here's San Diego County. We have various types of parent material, whether it's sedimentary from the oceans or volcanic material. And when you travel to different parts of the county, you can observe different soil types based on those different origins, the parent material. And when we pay attention to the topography and the climate, we recognize that soil will tend to go downhill as it erodes and weathers, breaks down into small pieces, it falls downhill. So at the top of the hill, you'll have shallow soil. At the bottom of the hill, you'll have deeper soils. And in the canyons, in the riparian areas, is where you have deposition from floods. And we also have a microclimate condition. So we have rainfall patterns that's part of our Mediterranean climate, but you can even observe microclimate patterns. The image on the left-hand side shows two different aspects of a hillside here in Southern California. And you can see that one side is dry and one side is more green. And what I could tell you is that the side that's more green almost certainly faces north or east. And the side that is more on the dry side with more exposed soil, less green, lush vegetation, that almost certainly faces south or west. And as you're driving around, you can try to observe these ridge lines on our hillsides and see for yourself what parts of the hills are the parts that are the most green. And we can conclude, therefore, would have more stable soils, deeper soils, and a faster rate of soil building. And this is simply a value of exposure or sun, hot and dry sun that aids in plant growth or limits plant growth. And in our part of the world, sun is, of course, good, but we want to always be watching out for evaporation and water retention. And so it's the north and east slopes of the hillsides that tend to hang on to the water a bit more, and the vegetation will respond accordingly, and therefore the soil buildup will also respond accordingly. And then how does soil build over time? Well, we've discussed soil formation, and there's this ecological concept of succession. Succession just means that there's one step after another. And over time, nature will move toward some sort of settled state, or something we would call a climax state. In the early stages, we call that pioneer, and then it goes through intermediate succession into a climax community. Mainly, we think of this with plants. After a disturbance has been visited upon a land, say fire, flood, human disturbance, the pattern of succession follows a very predictable pattern. And soil also has its own succession. And so you can see what happens above ground in some ways is dependent on how deep the soils are below ground. So we start with bare rock, and eventually the lichens come and they can start to grow on the rock. They facilitate the decomposition of that rock, breaking it down into little pieces. We get shallow soils developing where small annuals, mosses, plants can grow. As they grow and die, they continue to break down the soil further. They enrich the soil with organic matter. It gets deeper and deeper. The grasses and the perennials start to move in, which make way for the shrubs and certain trees. And then we have in the shade of those trees, typically the final climax community. And in our part of San Diego, that's the coast live oak. So the oak woodland is the final climax habitat type. And it's largely dependent on soil factors as well as shade from the sun and other sorts of things. Now, there's specific areas where you may never get to the climax. You may pause. And in San Diego, typically we pause at a chaparral or a shrubland. And so it's all dependent on various factors, topography, climate, but also time. Over time, about 100 years, you'll go from disturbed soil back to a climax community in San Diego. You'll get your oak trees back again in 100 years' time. So it's important to understand all this because soil is forming always, but we want to make sure we don't destroy or lose the soil faster than it can form. And the rate at which it can form is slower than what we want to wait for. On human timescales, soil formation naturally is too slow, which is why we would consider it a non-renewable resource. And when it goes backwards in time, we call this a regressive evolution. So instead of moving forward on that path to succession, it's going backwards. Something wrong is happening. And based on your general biome or your climate type on Earth, you will probably lose your soil in one of two ways. If you're in a wet climate, you probably have chemical deterioration, meaning it rains so much that you lose all your soluble nutrients. In a dry climate, you typically have a mechanical disintegration where you lose your soil due to erosion. We won't spend too much time talking about what happens in the tropics, but one of the key contributors to soil loss in the tropics is the way agriculture is done. And for thousands of years, slash and burn agriculture has been the practice. Now, I want to be very clear that this is not always a problem. Slash and burn agriculture simply means you move into a jungle, you cut down all the trees and you burn them, and those trees are turned into ashes, which then mineralize and enrich the poor soils in the tropics. Remember, tropical soils are poor in nutrients because they all get rained and leached out. Well, you have that deposition of minerals from the burned material. You start growing your plants in the recently burned area. Within 5 years or so, you have the forest growing back, and then you move on to the next spot. The problem is if you don't move on to the next spot. So if you let animals graze here, or you turn this into a palm oil plantation or something like that, then you've permanently lost the tropical forest. And that is that needs to rebuild for conservation value, for the habitat and the wildlife in the area, for the rivers, the watershed, the cleanliness of all the ecosystem services we say that the trees do. But also, if you're going to be able to ever come back here and do your agriculture in this area, you're going to need trees that will have formed with all those minerals. And so slash and burn should be called slash and burn and rest, because you need to move on to new areas every 5 years or so. And if you stay put in one area, then that causes problems. Slash and burn can potentially be sustainable, and it can potentially be non-problematic for a lot of the rare and endangered animals, because clearings in a forest in general are good habitat. But you have to work with nature, and you have to be in balance with the time scale and not overdo it. Oftentimes, slash and burn takes place in an area, and then now you've exposed the soil, and it rains so often in the tropics that this soil is loose and will move downhill. And if you allow it to be lost, then you need to move on because you've lost the soil. And that wouldn't be something we consider to be as sustainable. So it's a valuable technique to perform slash and burn. It can be done properly, but it has to be done very carefully because you have the opportunity to lose your soil. And as far as agriculture goes, this is one of the ways that we want to always try to be in proper scale. If we scale it up too big to an industrial scale, it just causes all the problems that we wouldn't see if we kept it at a small scale. Now, there is a technique that we'll watch a video on with adding organic matter back into the soil in a form where it's not lost to the rain. And so that's kind of an alternative or an addition to slash and burn agriculture, would be a practice that was only recently discovered by modern anthropologists and academics. It's been known for thousands of years with traditional cultures in South America, and it's referred to as terra preta, which is a special type of soil building that was practiced thousands of years ago and has caused certain patches of this tropical soil to become very rich in nutrients. We'll watch a short film on that shortly, and you'll have a better understanding. But let's focus now on soil erosion. This is what happens when you remove the vegetation from the soil. If you have bare soil, you will inevitably have erosion, because erosion is the wearing away of the land surface by water, wind, ice, or other geological events. And without vegetation, this process is much more quick. It happens more quickly. And that's one of the reasons we want to always try to cover the soil with plant material or with mulch, ground cover when we can, so that we can stop or at least slow down this process. So when water is eroding soil, mainly it's moving it around. It moves it from the hillsides where the rain falls, and it deposits that soil wherever it drops out. And deposition can happen all throughout the landscape, but we mainly think of it in our streams, rivers, waterways, where as soon as the water slows down, the heavy particles can drop and we have deposition. This is when eroded material is carried to low-lying flat areas. And sometimes this can be large volumes in the event of like a flash flood, where big pieces of trees, logs, boulders can be moved by the rushing water. And we will always end up with a familiar gradient where the big things settle out first, and the finer materials, especially the clay, will settle out last. The nature of this deposition can determine where eroded soils end up. So let's take a look at some footage of what can happen in flash floods, especially in dry lands. Here's southern Utah, and this is about 6 hours after heavy rain fell, and it fell about 40 miles away from where the person is filming this. And so pay attention to what it looks like when water can move all sorts of soil sediment as well as everything else that's mixed in. Now, this person is standing right in front of a moving flash flood. You absolutely never want to do that. The person literally could have died right there. If you are swept away by this material, you will not be able to swim out of it. You can see all of the twigs, sticks, rocks, mud. Barely any water is visible. It's almost a liquefied soil wave. So if you're ever in and around a floodplain in the desert, we're going to quiet this guy down. So if you're ever in and around a floodplain in the desert, you always want to be aware of potential rains that may be coming your way. This is a true life-threatening event to be in and around a flash flood in the desert. Pay attention to the color of this water. Consider all of the sediment that's being moved with this amount of water, and all of the changes in soil formation, soil deposition that is happening. We even see a large boulder, looks to be about the size of a vehicle, moved by this flood water. And as fast as this water forms, it will also be gone. And so it's something to understand and appreciate, especially right here with the wall on the left-hand side. I would not be standing there. It's very foolish to get in the way of this flash flood. Not something to laugh and joke about. There you have it. There is soil deposition in an extreme form, but it clearly illustrates the point of how water can move our soil around, not just over long periods of time, but very dramatically in short periods of time as well. So deposition may hinder agricultural practices if they contain a lot of rock fragments or coarse textures. You can see some images here of what it looks like after a flood has deposited debris material. Sometimes it's very rocky and sometimes it's very fine, as you can observe on the bottom photo there with a center pivot irrigating farm, and you can see deposited material from a recent flood event. Generally, when floods deposit material, it's lighter in color, it has less organic matter. It'll be a different texture than what you have below. And when you apply a different texture directly on top of yours, that will just really damage your soil structure. And it will affect the way plant roots grow. It'll affect the way water flows throughout your soil. And typically, if you get a deposit that's thicker than 9 inches on an agricultural setting, that's considered to be damaging. That'll mess with your soil structure enough that it'll be difficult to grow there in the future. So let's zoom in and take a closer look at what happens when erosion takes place. The first thing we'll look at is a single raindrop. A single raindrop falling on bare or exposed soil is much more devastating than you may expect. But there's a bit of force behind that raindrop, and when the raindrop hits the surface of the soil, we get splash erosion. This is when the energy from the raindrops will loosen soil particles and it sets them in motion. Now, if you have a flat land, a perfectly flat land, the raindrop will do minimal damage because it will hit the ground and the particles will go out in all directions with a relative similarity in their distance and their energy that they're moved. But if you have any sort of a sloped soil, even the flattest land is slightly sloped. And when your raindrops hit that ground, it will still send the particles out in all directions, but because the ground is sloped, you will have a condition where more of the particles move downhill. So these raindrops themselves are the start of the erosion process, and we want to ideally have them hit leaves or have them hit plants before they hit the soil so you don't lose those particles. Now, when lots of raindrops form on a surface, you'll end up with a sheet of water. And you can imagine like your driveway. If it's raining, you'll see the rain moving all at once, like little waves or little sheets of water. And this is sheet erosion. It's when water is moving over a bare surface in thin sheets. And what it does is it carries the loose particles, but it leaves behind the heavy particles. And you can see the image here with a pencil for scale showing some stones and how all the loose soil between the stones has been washed away, but the stones themselves have remained, and you get these interesting little pillars forming. And so this is kind of the next grade up of erosion, and we are starting to have water increase and move more and more material. Eventually, the water in a sheet will find a low spot. And when it does, it forms a little stream. And the smallest of these little streams is called a rill. So this is rill erosion. You can see the image on the right-hand side showing a hillside and all those little lines forming kind of in this bowl-shaped valley on a field. And this is when real erosion takes place, and it's the removal of soil by concentrated water running through little streamlets. And as you can imagine, the water will continue to move downhill and join bigger and bigger bits of water until we get gully erosion. And so we're not yet in moving like rivers or streams. It's still making its way down to the stream, but it gets bigger and bigger as it goes downhill. And so once we have gully erosion, we have the removal of soil along drainage lines, and this is caused by surface runoff. Once started, this will continue to move up. So you have this gully, this little eroded area. That hole in the ground will continue to rise up the hill as water forms a little waterfall getting down into this scar on the landscape. It will stretch it uphill. And you'll have the side walls will slump down into, you'll get little landslides that by gravity cause the soil to fall in. And it's a process that just continues itself. So wherever there is gully erosion, we want to do some kind of earthworks to try and prevent this from continuing. You can throw stones in here. You can make little earthen berms or little bioswales that try to pacify the storm water, but we want to slow this water down because the erosive force will continue and will worsen over time. And then we have wind erosion. Wind erosion is in dry areas where your soil has so little water that it can be picked up, and when you don't have anything to block the wind. So if you've got wind traveling between 8 and 20 miles an hour, that'll separate particles from the surface and set them in motion. There's 3 types of wind erosion. There is suspension, which is where the smallest of particles are picked up and carried away into dust storms and clouds, and that gets carried far and wide. Then you have saltation, which is where the medium particles will bounce along the surface. Think of it like the heavy sand on a windy day that kind of sometimes can hit you on your legs or hit you in the face if you're laying on the beach, and you get that little like a saltation or a pepperine feeling. And then the biggest particles will just creep along the surface and be pushed by the wind. So when you have wind erosion, you have, again, the separating of these different particle sizes, and then they get deposited in different areas as a result. So what can we do about it? There's several things we can do to control for erosion. We're going to go through them now. And I mentioned water erosion and wind erosion. So there's strategies for both. And of course, we are always advancing our technology for how to prevent soil erosion or to control for erosion. And many of these are the law now. When you do construction, you have to follow what they call best management practices for stormwater management. We want to prevent any of this soil from getting into the storm water, which in San Diego will go down to the ocean. We want to keep it on the land. So here are some techniques. If you're on an agricultural setting, you can try contour plowing. This is where you only alter the land in elevations that prevent anything from going uphill or downhill. And so this is similar to what we would call a contour map, where it shows the lines as elevations on the map. Well, you can plant your fields accordingly. And not only does it look really nice, but it makes it easy to access because it's not very steep. And when water hits a field like this, as the image on the right-hand side, it will, much more of it will soak in instead of run off, because you've run any machines or plows in line with the contours of the hillside. And so any water will, instead of flowing downhill, will flow along the hill. This is a great practice to introduce, and farmers are doing it much more commonly these days. It's a traditional practice that was always followed until we invented machines that could kind of ignore the slope of the land. And now we're getting back to working with the slope of the land. The only problem, it takes a little bit more time in your tractor. So it's a little bit less square and easy to calculate. It's a little bit more harmonic with nature, but the added benefit is well worth the extra time driving around to harvest or to plow these fields. And then in very rainy areas, there's terrace farming. So these are places that primarily grow rice in the tropics, Southeast Asia in particular. But we see terrace farming all over the place, even in Latin America as well. And it takes a lot of work to literally flatten the hillside, make a bunch of tables instead of having a slope. But it is an effective practice for minimizing erosion. And something like this would be done over generations. So new generations would add on to the existing terraces in a field such as this. This type of farming does not work very well with mechanization. So this is something we see primarily in traditional agricultural communities. And there's actually a tourist benefit to this as well. Now, a lot of people want to go and get their Instagram photo in front of a terraced rice field. And so sometimes these farmers make just as much or more with their agritourism as they do with the actual rice that they are able to sell at market. So in the developed world, when we do construction now, we have several strategies that are quite similar to this contour approach. We're wanting to prevent the water from running downhill. So we use different technologies. One of them is straw wattle. You can see those little brown tubes that are placed horizontally on the hillside. That is literally just put down. Usually it's a plastic net filled with loose straw. And as any soil flows downhill, it will hit the straw wattle and fall down. It allows the water to pass through and collects the soil. These are temporary. These are not meant to be permanent fixtures, But while you have exposed soil in place, it's a law, it's a requirement that you have to have erosion control efforts, and straw wattles are one of those erosion control techniques. Another erosion control technique is a silt fence. And typically you'll see this around the entire perimeter on any construction site. It's a very simple fence with a plastic type of material that goes down to the ground. And in the event of any flooding or any true real storm event that carries soil away, at least you'll trap all of it on the construction site and not let any of it go outward to other areas. Now, the image here is showing the silt fence doing its job, but it's also kind of extreme. You don't really want that much silt to be trapped behind a silt fence. It's there as an emergency precaution, and maybe they should have put some straw wattle also on this hillside so that they wouldn't have so much soil to move after the rain event, because that looks like it's about ready to fail and burst. But at least it is doing the job. It's a proof of concept, and it's a practice that we do with all new construction nowadays. And then there is jute netting or jute mesh. This is something you can roll out on a hillside, and it covers the entire slope. And it's not 100% solid, so you can plant plants right inside of this jute netting, but it helps to slow any soil erosion long enough for plants to form. And this will decompose over time, so it's a natural material that breaks down in the soil. And it's kind of a temporary measure to be able to install plants on slope so that they have enough time to get up and grow and stabilize the soil by the time the jute mesh decomposes. You can also see the sandbags placed at the bottom of the hill to stop any bits of sediment that's able to flow underneath the jute netting. And then we have a product known as Hydromulch. So what we see here is a truck. It is applying mulch. And mulch is just anything that you put to cover the soil. And in this case, it's most likely some kind of straw mixed with water and shredded up and made into like a slurry or almost a paste. And you can plaster a hillside with it, and you apply it with a high pressured hose. And they've also added a colorant in here so that they can see where it's been applied and where it has not. That green color will disappear in a few days. That's a natural material. But what they've really done is prevented the hillside from running away when rain falls on it. Oftentimes mixed in with hydromulch, you can put seeds. So you can mix some native plant seeds in with the hydromulch. And so just as the new rains come, you'll have seeds sprouting inside of the hydromulch. The hydromulch holds water in the hillside, helps to get those seedlings established, and it also does the job of stabilizing the hillside. Those two don't always go hand in hand, but when you incorporate seeds into the hydromulch, it's called hydroseed. And it's a good job. It's a good paying job, and it's used on large construction projects, really like freeways or areas where they need to leave a slope behind. And it's a valuable way to protect that slope until vegetation can come in and cover. In this case, if you're going to do hydroseeding, the sourcing of your seeds becomes very important, because any weeds, any invasive species mixed in are going to probably outcompete the native seeds you plant. And so I've worked on some restoration projects where they have hydro seeding taking place. And that first year or two, you have to be very diligent about removing whatever plants you don't want. If you can get rid of them in the beginning, then you'll let the good ones continue on. But if you let it get away from you, if you just ignore it, there's a chance that it could lead to a weedy hillside instead of a seedy hillside. So the quality of your seed becomes very important with a hydromulch, hydroseed restoration process. And then for wind erosion, we've got wind breaks. So planting trees against the wind is a very valuable strategy. Plants actually form one of the best windbreaks because it allows some wind to pass through, and that slows down the wind as opposed to blocking the wind 100%. If you block the wind 100% with a wall or a fence, you tend to have the wind go up and over, but then crash down on the other side and sometimes can cause worse wind than if you didn't block it at all. So using plants to create a windbreak is a very valuable strategy, not just on an agricultural setting, but certainly on farms. It helps to prevent evaporation, water loss due to excess transpiration, and it helps to hold your soil in place. And we can do this on a broad scale. So in areas of high wind, you can coordinate with your neighbors and everyone plants windbreaks. And these windbreaks could also be productive. So they would be either habitat source for native pollinators or predators for your pests. And it can even be some form of a crop as well. So more and more we're seeing farmers opt for a mixed use land application where you're not just growing annual plants. Maybe you would throw in some tree crops, perennial crops as well. And if you arrange them in a way that they block the wind, then it'll bring added benefits. You can also pick and choose which winds you want to block and which ones you want to encourage. So in San Diego, on a residential application, you may design a landscape that would block wind from the hot summer Santa Anas, the east and north facing winds that come down toward the end of summer. You may put some plants along that part of the property so that you can prevent the hot, dry winds from coming into the property. That could have some fire safety applications as well. But you may want to encourage the cool breezes off the coast. And so you wouldn't necessarily plant a windbreak for the cool breeze, but you plant it to block the hot breeze. So you can get quite technical with how you would arrange your plants in order to create a windbreak. And also on farms, we've got cover crops and crop rotation. We've discussed this in various topics, but we always want to have something covering the soil. And you may plant plants in between your traditional crops, so that way at least something is there to stop any soil erosion from taking place. Or you may choose to rotate your crops in time so that you can always have fertility in the soil and never reach a state where you've depleted the soil and then need to let the farm stay fallow or have the soil exposed and bare. So most of the time you want something covering your soil if at all possible, and cover crops do that. Now let's talk briefly about soil contamination. This is slightly different than soil erosion, but it's another problem. And there's many things that can pollute our soils. Some of them can be things like acid rain. So in areas of high rainfall, air pollution from industrial practices can get up into the atmosphere and can cause rain that's so acidic that it acidifies the soil and kills plants and living things. We also have pollutants, things like lead and petrochemicals, oil spills, natural gas, things like that. They can persist in the soil, and then the soil itself becomes contaminated. Any food you eat from that soil could also potentially be harmful to your health. So there are several strategies to try to clean up contaminated land. You want to do so very carefully, and you want to trust the science and do so with caution. After one little lecture, no one's ready to go out and do remediation of pollution, but there are several strategies. And one of those is actually phytoremediation. You can use plants to actually pick up the heavy metals, and the biological processes will break down some of these minerals into forms that are less harmful for people. So you can have petrochemicals, oil, pollutants be broken down by soil microorganisms, by plants, and you end up having the plants do the work of cleaning up the soil. Now, if you were doing something like this, you want to be very careful. Don't eat a plant that is cleaning up the soil, because it will be filled with those toxic elements. And also, don't just throw that in the compost pile, have it decompose and throw it back on your farm. You need to dispose of it properly and do so in a way that's according to science. But this is really an emerging field, this concept of bioremediation, using life to clean up pollution. And really, it all involves soil science and looking at pollutants in the soil. If you're excited about this idea, there's a lot of opportunity and there's a lot of need out there for specialists to learn the very intricate ways that living organisms, microorganisms in the soil, bacteria, fungi, can help to clean up and fix the pollution in our soils. So there you go. There's just a brief discussion on soil conservation with a focus on erosion and how erosion takes place and how erosion can be controlled or at least minimized in our landscape. Soil will form naturally over time. We can encourage soil to form as fast as possible, and we can enhance soil with biological activity that humans help to facilitate. But if we lose the soil, it will not return in a timeline that is meaningful to us. It takes a long time for a boulder to become sand. And so we want to respect the amount of time that it has taken, and we don't want to lose the soil that we have. So hopefully this gives you a greater appreciation for the soil beneath our feet, how precious it is as a resource, and what are some of those BMPs, best management practices, for preserving and restoring the soil resources in our built environment and in our natural world. Thanks a lot.